Unfortunately, a colleague of mine had to stay in Ljubljana because his father finished in hospital, the first one, PDF, in hospital, and so in the last minute he had to cancel this conference and asked me if I can present the paper. So I will try to read it as engaged as possible, because when he is lecturing, he is very much putting himself into it. Well, the title is strange. Some of the slides are very psychedelic, you will see. And what is Dimitrij trying to say is that we are about to embark on another level of working in archaeology, especially with landscapes and with aerial archaeology, and that is that we are dealing with what is now called big data. And big data is something that's completely different, that requires completely different ideas and approaches, as he termed cozy little hobbit words. So, is this one? He starts with quoting O.G.S. Crawford, the pioneer of pioneer of the aerial archaeology, and not just aerial archaeology, pioneer of landscape archaeology as well, by saying that history is like a carpet whose pattern can be only discerned from a distance. And O.G.S. Crawford continues, the reason why historians in the past had been unsuccessful in recognizing the pattern of history was due to inadequate data. As he puts it down, Crawford, you cannot see the pattern of a carpet when only a minute portion is uncovered, and you cannot discern the pattern of history until large portions of it are available for examination. I believe everyone who teaches aerial archaeology shows this to students, so no new things. Being embodied human agents, we feel most at home with things that fit in our hands, such as artifacts or features that can be explored and negotiated using our bodies, such as buildings, features, and sites. Engaging with bigger entities, such as landscapes, gives us a sense of impotence, as we cannot rely on our bodies to provide sense of scale anymore. Aerial archaeology has continually demonstrated the importance of systematic observation of larger spatial units, and the fact that sites, features, and structures can be explained properly only in the context of their wider landscapes. However, when we talk about landscapes in archaeology, we still think about region-sized portions of land shaped by mostly human agency that left distinctive traces in them. Landscapes, as we understand them, are manageable areas of Earth's surface that can be covered and understood by a single person or a small team. And now, this is what he terms our cozy little hobbit words. Why should we leave those cozy little hobbit words behind and tackle large, big, vast things, entities that are much larger than our regions? One of the reasons is contemporary discussion on a new geological era, the Anthropocene, characterized by the acceleration of environmental change driven by humans. Although Anthropocene is manifested locally, we all can feel it, the Anthropocene is global. There is a common pattern and forces behind the fact that landscapes around the globe are rapidly changing faster than ever, but how much faster? Faster comparing to what? Archaeology, as discipline that study relations between humans and the world in long-term perspective, can produce key data and insight in those questions. Archaeology can contribute a deep time perspective on the role and impact of humans in the change of Earth systems using cross-disciplinary tools. Archaeology can make a significant contributions to understanding how humans through their daily practices and projects, have shaped the Earth. And as landscape archaeologists, this is at the core of what we do every day, meshing individual agency with broad-scale patterns through time and space. Contributing to the questions of the Anthropocene requires leaving cozy hobbit worlds behind and tackling entities much larger than manageable archaeological regions. This change of scale, thinking and working big, challenges many assumptions about the nature of knowledge, the ways we produce knowledge in archaeology, and our relations of the data. And how to leave borders of the Shire. There is a new entity that is becoming more and more important in the contemporary life called big data. Very large data sets that are defined as to be big in volume, velocity, variety, veracity, and variability. Big data is a broad term for data sets so large and complex that they become awkward to work with using on-hand database management tools. Challenges working with big data include analysis, capture, data curation, search, sharing, storage, transfer, visualization, and query. Over the past decades, the quantity of high-resolution aerial and satellite imagery available to archaeologists has been expanding exponentially. Commercially acquired sub-meter resolution satellite imagery with spectral coverage in the visible and near-infrared with global coverage is continuously produced, and archived data is increasingly easy to access. There is still largely untapped potential of archival data with millions and millions of aerial photographs collected over the last 100 years or so. And there are prospects of crowdsourced data with data collected by individual drones and available on the internet. If we want it or not, we are already faced with big data. There is always more available remote sensing data for any piece of Earth's surface than we are able to process using traditional methods. And as we process and interpret our data, new data has been produced and available. The experience of large-scale mapping projects, such as monumental national mapping projects, show that traditional ways of dealing with data is impossible. The understanding of big data only as a quantity is unsatisfactory, if for no other reason than the circular problem of defining what is big and what is only large. The real epistemological problem with big data is not quantity of data, but a new quality that emerges from this vast quantity. Thus, the solution for big data is not of more and better techniques and technologies to shrink big data to a manageable size, but in rethinking the epistemological status of big data and understanding what is the new quality that it brings with. Big in big data is in relation to us, humans. We embodied human beings are not equipped to see and comprehend the intangible entity that is big data, unable to fully interact with it, and incapable of evaluate the meaning of these interactions. Compared to the small data, which is high accuracy, less errors, and high quality, big data is inherently imprecise and messy. While previously mostly everything was signal, now 99% of it is noise, which can completely overwhelm us, especially if we are unable to adequately filter the information. For each single piece of the Earth's surface, there can be thousands and thousands of different images and data sets in different wavelengths, collected with different sensors, with different resolutions, at different times, with different atmospheric and ground conditions. No matter how highly correlated these images are, no matter how high is redundancy and dimensionality of these data sets, each of it provides unique perspective on the Earth's surface. The radical change in noise-signal ratio of data makes human-data relation asymmetric. there is a sense of very uncanniness and helplessness in relation to big data. No matter how much we try, we cannot ever fully comprehend it. However, if we accept messiness of big data and surrender the urge to making it small, neat and unambiguous, we can get a load of new information in return, new things to consider, new opportunities to gain. We get scale and trends, very deep micro detail, longitudinal baseline measures, normal deviation patterns, and so and so. Dealing with inherently messy big data requires new modes and skills of interacting with such data. Big data requires new modes of using data for knowledge production that extend and complement the traditional scientific methods such as deep learning, hierarchical representation, neural networks, and information visualization. Big data also changes the way how we engage with the data in the first place. It requires that we delegate our cognitive abilities to non-humans with computer algorithms, and humans work together, where the machine handles the large majority, maybe 99% of the routine repeatable work, and humans dealing with the rest, mainly posing questions, examination, and interesting patterns and handling exceptional cases. There are already available tools that can handle manual and repeating boring tasks, such from registration of aerial photos to automatic segmentation, detection of features. Although interpretation of archaeological features is still uniquely human skill, specialized algorithms can at least isolate potential features and assist operator in interpretation of archaeological features. A rapid development in the artificial intelligence, especially in the field of deep learning, such as convoluted neural networks, makes computer algorithms performing skill-based tasks with much greater speed, precision, and accuracy than humans can do in a foreseeable future. We might expect that computers will be able to perform feature interpretation in the next few decades, if not years. And there is the fast approaching and eventual possibility of non-human agency in discovery and a potential moment of tools becoming more advanced than humans. This could lead to computer programs not just assist in knowledge production, but actually producing knowledge, leading to non-human entities that are able to see more than us. But what big data enables us to see? Hyperobject is a name for very big things, massively distributed in time and space, as defined by Tim Morton. Global warming is a hyperobject, as well as the styrofoam or plutonium we have ever produced. Hyperobjects are real things, not just some social constructs. However, we can think hyperobjects, but we cannot see them directly. We cannot touch them. They are too big, too distributed in time-space to be comprehended with our pesky human bodies. Big objects have always already been there, but it has been possible for most people to ignore them. With big data, these entities become painfully obvious. Landscapes are hyperobjects. We can see sites, we can see anthropogenic traces, but we can see topography, vegetation patterns, and so. That is what we landscape archaeologists are studying. However, we can't see the landscape in its totality. This is one of the reasons why there are so many definitions and understandings of landscapes. We can never see it in its entirety. Only facets are available for observations. Nevertheless, landscapes are real and have some kind of downward causality on sites, traces, geology, topography, and vegetation pattern. Therefore, we can think landscapes, but we cannot touch or see them fully. Landscapes last for a very long time. They are massively bigger than individual human life in time-space terms, and they completely outscale us. Landscape is thus not some cozy little hobbit world. Landscape become hyper-objects. This means that traditional ways of engaging with landscapes as something we contemplate and study from a distance becomes a romantic fantasy. This is the old pre-big data, pre-hyper-object way of doing landscape archaeology. Hyper-objects so massively outscale us that they magnify the weirdness in the things of our study. Traditional understanding of landscapes as kind of fixed containers that hold things are crushed by hyper-objects. Landscapes are, of course, full of things, objects such as archaeological traces, sites, stones, vegetations, etc. But in order to understand them as landscapes, we must approach them as networks or assemblages of objects massively distributed in space and time. The landscape is therefore more a pattern of linkages between diverse and seemingly unrelated phenomena at a very different scales of time and space than a thing itself. Landscape thus becomes a way of understanding objects rather than a specific class of objects or an object itself. Being landscape archaeologist means being sensitive simultaneously to the sensuous specificity of each discrete element of a landscape, site, archaeological feature, artifact, and of the overall effect of always evolving configuration. A key point here is what we landscape archaeologists already know. Landscapes are not fixed and static, but because the objects involved in the configuration are acting and reacting to one another, are perpetually unfolding and changing. The effects of configuration are emergent, as the results of configuration is distinct from the sum of the force of each thing considered alone. This means that observe is not appearance and change of things and features, but looking at long-term behavior of landscape, especially moments when landscapes radically reconfigure themselves, when becomes a landscape something radically different as it was. Well, when landscape enters into a phase change, whether it be a human historic event, a cataclysmic physics change, or some other incident that marked the intertwining of the landscape with something else. For example, a pattern of land and field systems around us creates landscapes that evolve and revolve. It will be very soon finished. At the moment, Hillfort is abandoned, either due to the climatic change, some economic conjuncture, political event, some possible radical change of new landscape will emerge, with old landscape being preserved only in the form of material residuals. Big data study of landscapes must be thought as the cartography of the space-time of these relations between different entities and objects, investigating various local manifestations which emerge from their interaction. This call for novel, intricate, and complex tool of mapping for those relations. Mapping landscapes could benefit from cross-breeding with other disciplines and alternative ways of mapping, particularly maps that permit quantification and measurement. Just a second to find myself in this slide. Yes. Thus, for example, we might supplement traditional mapping with the tools such as topological maps that put relations in a measured space, material flow maps that quantify the map flow of substances and people through landscapes, or odom diagrams. This is a case of how there was the social gravity of Manhattan in the 18th century, the island of Manhattan. So it shapes a map of interactions. So at the end, this is what I believe is a brief glimpse of the carpet that O.G.S. Crawford was talking about. Big, massively distributed entity in time and space, operating at the age of chaos, following the strange attractors and bifurcations, never fully visible, perceived only by non-human deep neural networks in a vast cloud of big data. but I'm not sure whether O.J.S. Crawford would like it. Okay, that's it.